My conversation today is with Rob van Looveren from the Netherlands, a railway consultant, and we're talking about the situation in the Netherlands around ERTMS, ETCS, and especially the migration from the GSM-R radio system, the original one for ETCS, to the new upcoming radio standard FRMCS. Please like, share, and subscribe this channel and this episode. Please enjoy my conversation with Rob van Looveren. Rob, welcome to the show.
Thank you for having me in this podcast.
You're
Shall I introduce myself?
Yes, please. I was going to say it's the first time that you're on the podcast, so please let us know who you are, what you do, and what your relation is with ERTMS and ETCS and radio and so on.
Yeah, so my name is Rob van Looveren. My background is much similar to yours. I think I studied on the Technical University in Delft in the 70s, so to say. After my studies and after military service, I went to work with KLM, our Dutch air company. And there I got a bit in automation. And after a few years, I left there and I went to work for PTT Telecom, which was a governmental organization at that time. And later it became KPN Telecom. It was privatized. They didn't do it in the best way, but anyhow. And so I worked there for 23 years. And then they they let me go because they had to reduce the company, the size, the employees. And I never got a paid job after that because it was in 2008. There was the financial crisis. So, and then I thought, yeah, what to do? And then I was always interested in railways. And that was, say, 2012. In 2012, I started to reading subset 26, 026, 026. And it took me 2 months to fully understand what they were saying. So that was my start with ERTMS. And then the year later, I said to my friend Peter van Katz, okay, I have a nice idea. We have to focus on freight trains and to see if we could fill in something for level 3 train integrity. But that's still not yet filled in, that part. But we have developed our smart freight train ID to put all sensors on wagons and so on. But that shall be waiting for FRMCS to be feasible to create that in Europe. I think it's not an issue maybe for Australia. Okay, so that's a bit my career up to now. I'm also involved in European-funded projects, which was all about transport and logistics. And I'm still involved because after that project, we raised an association without profit, and I'm a member of that association, and we prepare also new calls for all these funding projects in Europe of the European Committee. So that's now a new challenge, but that's just part-time, and that's now going on. And before this meeting with you, you said you want to talk about FRMCS. So with the help of AI, I made some surveys on where we are now with FRMCS and ERTMS, ATCS also. So that's it then.
Yeah, so let's talk about FRMCS. You mentioned this. Can you explain to the listeners what this is and why it is so important?
Yes, we have ERTMS operational in Europe, but it's all based for the train trackside communication on GSM-R, the second generation mobile network. And since the provider said, "Oh, this technology, I stopped with producing that," so we have to go to change to another network. And the 5G, 6G technology give is then the choice, the new choice. But the big difference between GSM-R and 5G is that GSM-R you have to connect to trackside to the radio base station via the telephone network and GPS facilities. So that with the new network technology, 5G, 6G, and so on, we change to a technology which is Internet to the edge. So you can then skip these telephony protocols and so on, that technology, and directly build on the Internet protocols. But that's quite a change because we have a lot of trains already running with the old equipment, and that transition to FRMCS, because that is based on 5G, of course, that facilitates a lot of things for the railways. But the transition phase, you have a lot of trains running with on GSM-R. And on board, we have then your radio part of it to communicate, but that shall be replaced and by the an FRMCS 5G equipment. And also the radio base station uh, needs facilities to communicate with the 5G network. So that's quite a challenge that transition in Europe.
Yes, and there's only a certain window of time to do this, right? There is I'm not quite sure what the timelines are in the Netherlands, but there is a an end date for GSM-R support that I've heard of, and it will also take a bit more time until FRMCS is fully specified. I think they're currently running tests, but tell us more about this, and maybe you know best about the situation in the Netherlands. So, what are the timelines in your country?
Now, so uh, when I was in the Phoenix project, I and Peter van Katz, we helped UIC with making these functional requirement specifications because they only set it up for passenger trains. And we told them, oh, we know all about these freight trains, so we can help you writing the specifications for the freight trains. And so we did during the timeline of that Phoenix project. Uh, but the further development is still going on, but uh, next year they will start really field trials and so I don't know the exact flow of all those activities, but also the specification for baseline 4 will come. That will integrate also FRMCS. And then yeah, the I think from next year on, uh, transition phase will start, but that will run up to 2035. So that's a almost 10 years transition phase.
Okay, so 2035 is the end date for GSM-R.
Uh, yeah, but the transition is quite complicated because you have already equipped trains, and when you're not following a specific plan that you have the right trains for your corridors, trains can't run. So that's very precise planning of also the getting the equipment, the trains ready for that.
Yes.
And
Yeah, but
at
it's
the end,
important. It's important to know what the timelines are. Yeah. So if there is a hard end date by which all the GSM-R must have been taken off and switched off and decommissioned, that's an
yeah, yeah,
important milestone to know, so that you know how much time you've got available for your migration, right?
yes, of course, yeah, yeah, but reality tells us also that there will also be complications. So
Yeah.
we'll see where we are in 2025. And maybe on some parts there will still GSMR be operational. They just keep it running. They can use old equipment which comes free to replace broken parts or whatever. That's also for telecommunications possibility to to
Yeah.
keep it running and yeah.
Yeah, I agree. I think it will be a slow and painful death to GSM-R in some areas. Yeah, and I could imagine that railways that just can't get the migration done in time, yeah, they will try to cobble something together and keep it alive somehow without industry support. I don't really know how that works, but
Yeah,
maybe
yeah,
they have some in-house resources that are close to retirement but still can be convinced to do a couple of years more. And yeah, but
yeah.
I
But
mean,
the
eventually they will
possibility.
have to go to the new technology.
Yes, of course, yes, but they cannibalize just all the equipment to keep operational parts running.
Yeah, yeah.
But in Europe, the main focus is on our 10T corridors, the main corridors for the railways. We started with 9 corridors, but now we are maybe at 12 or more corridors defined uh, for the main streams of especially the goods transport, because passenger trains they run normally only in national, and there are just not so many who are running international in Europe
Mm.
because due to all extra equipment to install for the different countries with different signaling systems. That's the current situation. And we will to go to one railway area in Europe with ERTMS as the security system, the signaling system.
Yes, yes,
That's
that's the objective, but it's not going as
yeah.
fast as the Europeans were hoping for, right?
Oh no, no, oh, no. No, when we have the European Railway Agency,
Yes.
uh, yeah, and they uh, were moved in a position that they will control all developments and introductions in 2016. But then already there were ETMS equipment installed on locomotives. And the national authorities then said, "Oh, we are responsible for the safety. So could you adjust that and that and that?" So the Alstom and Siemens and who delivered the equipment, they made changes. And with those changes, the system became not interoperability anymore.
Mm.
So that that's the era, as we call the European Railway Agency, started in a position that they were challenged to harmonize it in the whole of Europe. So that was not so much ideas about how you do version control of all these specifications.
Mm.
But there are different suppliers for the equipment on board, and they I've seen the first built ERTMS equipment for the trains. So it's quite a cabinet, a lot of electronics. Nowadays, it's getting much smaller due to thanks to ASML, who made possibility to made these very tiny chips. So there is there it's created all kind of legacy for that starting situation,
Yeah.
and that hinders, of course.
Yeah. You mentioned you wrote some specifications for freight trains. What specifications were those? What was specified there?
Oh, that was focused on the use of the capacity of the FRMCS network, so they could uh, could build it for what needed. But for the passenger trains, it is much focused on providing internet access to the passengers. But for freight trains, you don't need that, of course.
No, but
The
do
but
you need the safety critical stuff, right? The ETCS. Yeah, that it's
yes, that of course.
yeah.
But we also specified all the operational processes for freight train operations, and and we wrote this also to with the IDs of our smart freight train ID that all wagons are also equipped with sensoring stuff to see if there something going wrong with brakes or hot boxes, all that kind of stuff, and that can then be communicated to the train driver. But that's just our ID of the smart freight train. That's an extra.
Hmm. Okay. Um. So you said that the migration may already start next year. So I, to my knowledge, they are still working on the final specifications of FRMCS, and
Yes,
they're
yes,
currently doing tests in Moraine 2 in different countries to
yes,
inform any necessary changes to go into the next version of the specifications for FRMCS, hopefully the final version. Um,
yes.
so what makes you hopeful that the migration can already start next year? Because obviously, in order to be able to do the migration or to start the migration, you need to have products. You need to have products for the radio system itself, but
Yes, yes,
you also need to for the ETCS trackside system, the radio block centers to connect to FRMCS, and you also
yes.
need, importantly, you need equipment on board of the trains to interface with FRMCS. So, what is the status there? Do you know?
I asked it to ChatGPT if they already have the radio equipment for FRMCS for on board the trains.
Hmm?
And I got an answer, no, that's not yet there.
Yeah, yeah.
Yeah, but these are yeah, not the big questions. And the industry can really fast produce that equipment. That's not the main problem. But
Hmm.
but when you make a transition, you have to make the trains ready with for FMCS, but you also need to make the radio base station, the RBC, ready for
Yes,
FMCS.
yes, yes, yes.
And, and that complicates the transition because the radio base station, okay, that is along the lines. You have different of those stations. That's not so big number, but the trains running on that corridor, they should all be prepared, and they are owned by different companies. So that can be tricky, and in the worst case, after transition, some companies won't couldn't could not run on that corridor then. So that's yeah a planning issue or an alignment issue and so.
Do you know how the migration strategy in the Netherlands looks like? What
Um,
the sequence is of fitting vehicles,
yeah,
maybe
that
dual
changed.
fitting vehicles?
That all yeah, I don't know in detail because it changed in various times. Now they started just in the north of the Netherlands with I think the line between uh, Well, just a small line. They will start near Delfzijl, I think.
Mm-hmm.
So
Okay.
that's very isolated in the north. Not so much to do with other railway lines and so on. Because when you start in the center of the Netherlands, in Utrecht, for instance, yeah, they're most all trains in the Netherlands pass there. So then that's not so. In a corner of the Netherlands where not so much trains running, it's safe to start, I think.
Yeah.
So then you can see what troubles it give after you've become operational.
Yeah. I mean, there are probably multiple possible strategies for migrating to FRMCS. I think the most likely will be that the trackside equipment will be transitioned gradually from GSM-R to FRMCS, which means that you will have a mix of GSM-R fitted lines and FRMCS fitted lines. And
Yes,
that
yes.
means that you need trains that can work both on GSM-R and on FRMCS. So that's at least how I would foresee it, which means you need an onboard system, an onboard radio interface that can interface both with GSM-R and with FRMCS and can switch dynamically when there's a transition from a GSM-R area into an FRMCS area. Is this how you see it as well? Or do you think that there's a different strategy in the Netherlands?
Um, I looked up things and that is just a complicated transition because what you should go uh, you prepare everything and then you make the transition and then you're in the new situation. That's what I got as idea from what I read.
Mm, mm,
But yeah, the making the trains ready at time and then it's how because parallel, yeah, there is a kind of solution, but I don't have it in my head now how that precisely looks. If you because with the RBC you can't run them with both networks. I think there's also a problem.
When it comes to your training on advanced signaling and train control, nothing beats a good quality. That's why I partnered with the Informa Connect Academy to create 7 fantastic online trainings that I believe are the best and most comprehensive portfolio of online trainings in this space in the entire world. You see the 7 trainings that I'm offering through Informa in the boxes here. And you also see at the very top a web link where you can find information on all of these training courses. If the education and your personal development in the field of advanced train control is of any importance to you, I recommend highly that you check it out. And I would look forward very much to welcome you in one of these training courses. All of them have interactive elements, so we can actually meet face to face in those trainings, even though they are online courses. It needs to be seen to be believed. And now back to the conversation. So I think you will the trackside transition will be in line with the RBC control areas. I think has to be.
Yeah.
And but that again leads to a situation where you will have a patchwork between GSM-R fitted areas and FRMCS fitted areas, and the way to deal with that is to have trains onboard equipment that can deal with either of the two radio systems, because the other alternative would be a dual fitment of the trackside, and I don't think that's a
Yeah.
very feasible idea. Yeah, then you would need to
And,
have an
and
RBC that can switch between No, that
Yeah,
doesn't work.
but
That doesn't work at all. When I think
no,
about
that
it, that
doesn't
no, that
work.
doesn't work
You
because
have
then
to you
then
have to stay safe.
yeah, well, and you would have an RBC area controlling different trains, and some trains run on
Mhm.
GSM-R and some trains are
Yeah,
on
yeah,
FRMCS. So the RBC couldn't switch the radio systems back and forth depending on which train they're talking to. That wouldn't work. So I think we're back to the other idea of migrating, that you transition a trackside area from GSM-R to FRMCS, and that's it. And then you do
yeah,
the same thing section by section by section in accordance with the RBC control area. So I think the RBC areas will be the cells, if you will, for which the radio system needs to be migrated. And yeah, and then you need capable trains that can do both. And
yeah,
this will
yes.
be necessary anyway, because if you think about freight trains running international, even if you say the entire part of the freight train journey in the Netherlands, it's all migrated to FRMCS, and then the trains goes across the border into Belgium, and they haven't migrated yet. And then again, you need the train to be able to deal with both FRMCS and GSM-R. So I'm here in Australia. I'm a very strong proponent for having such a bistandard approach on board. That the trains must be able to deal with both radio systems and can basically switch between the one and the other, because I believe that's the most feasible migration strategy. Maybe even the only
Yeah,
that really works. Yeah.
yeah. I already discovered that you have your communication boxes in onboard trains, which can switch between satellite and the network and so various possibilities,
Yeah.
which is not common in Europe. And yeah, but Netherlands, we have a very dense railway network for passenger transport. So for us, it's a horror, that migration plan, because did you encounter a point where just a line can't be run by all trains for a time, I
Yeah.
think. But I don't know the details how they will do it. This so we'll see. I don't,
The
but those are technical details which will block something and so on.
Yeah, I think it will go back to the old problem that ERTMS had all the time. For the migration strategy to work, ideally you would have to fit the entire train fleet with the
Yeah,
bistandard
yeah, yeah.
onboard system before you start the trackside migration. So that means that the onboard equipment needs to invest first. And that's
Yes,
so
yes.
then you have the problem, as you mentioned, you've got many different operators, some of them quite small, just with just a few locomotives, and they now need to touch their ETCS onboard again and need to upgrade it to be able to deal with FRMCS as well. And they will have financial struggle to do so. They will say, well, I understand that this may be necessary from a national point of view, but who's going to pay for it? I can't afford it. Yeah, and that's the same struggle that they had previously with fitting ETCS in the first place. Who pays for it, and if they have to pay for it themselves, where is the return on their investment?
Yeah, but retrofitting a locomotive is very costly,
Yes.
and yeah, so that's a major problem. But for we have in the Netherlands, we for passengers we have the Nederlandse Spoorwegen, NS. They run the main lines, and a few side lines. There's another train operator. So the major part is only of NS, and the side lines is now also for other companies to run. So that's, but for the freight trains, we don't have an own freight train operator. It's all German or from abroad,
Hmm.
and those trains mostly run from the ports directly to Germany or to the south, because we are a small country.
Yeah. Yeah.
And it's just 200 kilometers from the port of Rotterdam to the border with Germany.
Mm. Yes.
So that's nothing compared to Australia.
Yes, it's much shorter distances, but still, yeah, the migration is quite complicated. Yeah, I think in Australia we may be in an even better position than Europe because we haven't got this much of an installed base for GSM-R. So we've got some railways that are just starting out and they can start out straight with FRMCS. So they don't need this migration. They just go to FRMCS and then they're fine. Um, so um,
Yeah, I think there's another difference between Europe and Australia. So in 1989, the Commission has said, okay, we will after the fall of the wall in Berlin, maybe you know that. Then they have said we will make one railway area in Europe.
mm,
All the national networks are connected with each other, and the situation is in Australia is different because you have near around Perth, an area where part of the population lives. Then you go to the southeast, Sydney, Melbourne, there. Those are the main areas for Australia. But in between, you have also the plains, the outback, and that separates these areas, in fact, from each other. So
yeah,
you
but
have
we do have a railway there, so it's not completely
yeah, you have a
separated.
there.
Yeah.
Yeah, but in the European view, they have no idea of these uh, these rural areas without any telecommunications except satellite available.
Yeah.
That's
I mean, maybe the interoperability topic is a bit easier here in that you can't have that many railway jurisdictions that running their trains back and forth. So for instance, if you are in a country like say Switzerland, somewhere in the center, or take Germany for example, they could get trains from the Netherlands, from France, from Denmark, from Austria, from Switzerland, from Belgium, and then trains coming from even further countries, from Eastern Europe, from Belarus, or from the Latvian countries, or so, the Baltic countries. So in Australia, the main topic for interoperability are really the freight locomotives. So um,
Mhm.
the network connecting the cities is basically just operated with locomotives. So once you fit those locomotives, then the interoperability challenge is if those locomotives go into cities and operate on parts of the city networks. That's where we need interoperability. And then, of course, for the interstate network itself, within the interstate network, yes, we need interoperability as well. But that should be an easier task compared to Europe, where you simply have more players involved, more different railways involved with different histories and different signaling systems historically and so on. So yeah, so it's less complex
Yeah,
here,
yeah.
but still not easy.
No, but yeah, you have that's still a big difference with Europe. We are all connected within all European companies, countries, and we have yeah. What separates in Europe is the Alps. That separates Italy from France and from Switzerland. Switzerland is a bit apart because they are not member of the European Union, so there's a kind of an island. But for railways, that's not a problem, and they facilitate much by boring these tunnels through the Alps to go to Italy because the big economic uh, parts of Europe is the northern part of Italy and then Germany, Netherlands, that there with the Ruhrgebiet. You may know it in the west of Germany.
Mm,
Those are hotspots for economy.
mm,
Uh, so there, the first the the first 10T corridor was also projected from Rotterdam to Genova in Italy.
Yeah. Yes. You mentioned earlier the smart freight train concept that you were working on. Can you tell us a bit more about that?
Yeah, that we started this. It was triggered the idea because with for ETCS, the train integrity was mentioned, but they didn't solve that part, and it's still kept outside. But we did, yeah, we talked with the people how do we connect all these freight wagons with the control equipment of the train driver and all local solutions for onboard the trains were not feasible to cover the whole train because technology didn't accommodate that
Hmm.
because a train is quite a length and we run then trains up to 750 meters, but you have much longer trains. You can make a network on board all these wagons. So then the idea of FRMCS came up, and my colleague said he is more the specialist for the radio. He said, that's a solution. We can easily, because the internet is to the edge, so you have internet access direct. You should create it directly on board your wagon, and then you can easily make your applications with the technology, and and then you connect via FRMCS. You can easily connect with the unit in on board the locomotive, the head of the train.
Yes.
But it's still an idea on paper.
Oh, okay, okay, okay. I was so you would probably the issue was train integrity for trains that consist of wagons and can vary in lengths and so on. That has always been the big problem.
Yeah,
And the the trick would be you would need some kind of equipment on the last wagon that basically tells the locomotive I'm the last wagon and I'm still behind you. I'm still there. You haven't lost me. But that
yeah,
would
yeah, that's correct.
mean that you would have to put this equipment on different wagons depending which wagon is the last one.
Yeah,
And yeah, and then the locomotive will need to have the other part of the communication uh, receiving
yeah,
signals
but
from and then you go through a curve and then the back of the train is closer to the front because of the curvature and so on so there are yeah it's not
yeah,
a
but that
it's not a trivial issue, that's for sure.
no. So then we have to go to the United States where everything started. They run in at first long ago trains with a caboose at the end of the train where crew was on board. But then they could get rid of this caboose by creating the end of train device.
Hmm.
So you mount that on the last wagon,
Yeah.
connected to the brake pipe, and you have a radio connection with the locomotive. But when distance are no okay with the radio you can direct radio you can cover up to 10 20 kilometers at the max, but that's okay that you can do. I think and in the that end of train device is much used in the United States, but in Europe maybe few, but
Hmm.
not that many. When you don't have equipment on all the wagons in between, huh? So, but with the idea of detecting those anomalies occurring on railway wagons, you should install sensors on each wagon, and then you have the problem of communications to the train driver. That and creating a network which goes from train to train with the communication, yeah, that we found out that was not feasible. That There
Yeah.
were they couldn't accommodate so many hubs and so, and then it will get blocked, the communication, so on. Didn't work.
Mm, mm,
So
mm.
with FRMCS, you can have communications from each wagon via the FRMCS network, the 5G network, to the locomotive then.
Mm, mm.
That can work. But you need a network. So in the outback, you have no network, so it won't run
Oh
there.
no, we do, we do, we do, we do. You would
Yeah,
you would be you
because
would be surprised. We're not that far behind in Australia. We actually do have a radio communication network along our interstate rail network, and yeah, it's
but,
only
but
it's
much
only
it's based
4G.
still on.
It's only 4G, but FRMCS will work over 4G. So we actually do
Yeah, yeah,
have
yeah, that's
a
possible.
strategy for doing this. Yeah, so it's not quite as
But
bad.
but but is it using satellite?
No,
Uh,
no, it's
Just
normal.
antennas. You have
Yeah, yeah,
antennas.
yeah, yeah. Normal radio infrastructure. Yeah, yeah. So
Okay.
there was a deal for the interstate network between the network operator and the biggest Australian provider for mobile telecommunications. That they can
Yeah.
build their infrastructure, their radio infrastructure along the rail corridor, and the railway can use the radio for their applications, for their signaling applications, such as FRMCS in the future. So it's quite a good deal for both sides,
Okay.
and that leads a long way towards getting a solution there. Yeah, so it's
Mm.
we are quite good in that regards. In the meantime, it was different a few years ago, but now we're kind of okay, I think.
Okay. But that's quite an investment, I think, because you have to install many antenna locations.
Yes, yes, yes. But it's the biggest telecommunication carrier in Australia. So they
Mhm.
always had the best coverage, including in areas where other carriers didn't have coverage, didn't afford coverage.
Mhm.
And they saw it as an opportunity to become even better, to have an even wider coverage. And if you have something along the rail corridor, then that's obviously good for passengers on the train that run there. There aren't many passenger trains anyway, but the ones that they do, they have now
Yeah,
better
yeah, yeah,
better
yeah, yeah,
reception
yeah.
as well. Yeah, and of course with radio systems, you also have coverage a few kilometers away from the rail corridor. Um, so you can start building on that. Good. So how do you see your activities over the coming years? Do you think you will have any involvement in that FRMCS migration, or have you
No,
got
no,
other
no.
plans?
We- I'm more involved in that FENIX association with preparing all kind of proposals for funded projects in transport and logistics. And the project we did run was creating a cyber secure uh, data exchange between data spaces, so to say.
Mm-hmm.
And that that is that we will deploy within other projects to create telecommunication links which are standardized, so to say. Because with that we created the possibility that you can create those trusted data exchange, very cyber secure, and so on. But you can then use your own messages to transfer, because the concept is between these connectors, we call that connectors, you have one standardized message, but you can put any type of message in the payload, and that makes it flexible.
Mm-hmm. Mm-hmm. You
But
you did.
but there's still a lot of work to do
Yes, yes, yes.
for
You
standardization and so on.
you did mention you were also involved in some European research projects. Do you want to talk about that, or is that top secret? Because
No, no, I was not involved in a research project. No.
okay,
No, this is the only we run that FENIX project lasted 4 years.
Yeah.
So that was, and I was much focused on interoperability because the main challenge was to build the IT technology. But yeah, using that IT technology, you should know how it runs in real life. You have to look at how parties work together, collaborate together, communicate together to see what is needed, and then you have to agree on for these supply chains on standardized messages. United Nations did a lot of work in the past already. They started very long time ago with the oh come on ADFACT. Then in that time it was a lot of port-to-port communication, so on. There were only possibilities of leased lines with low transmission speed. So they made a standardization which you can make your messages as small as possible, so you have really affordable transmission times. But nowadays that's no problem anymore.
Mm-hmm. Okay. Well, thank you very much for giving us a bit of an insight what's happening in the Netherlands. So let's hope that they sort out the challenges of the FRMCS migration and they can successfully phase out the ancient GSM-R technology, right?
Yeah. Sure. Yeah, that will be still a challenge because in Netherlands we keep a lot of talking about these things, but you have to make a step to practical approach to really make that transition.
Yeah,
Yes.
that's true. Thank you very much for your time, Rob, and all the best. Bye-bye.
Thank you for having me. Bye.
Bye. Hi, it's Doc Frank again. I hope you enjoyed this conversation. If you like the content, then the best way you make sure that you don't miss out on any of the future episodes, just subscribe to the channel. By doing so, you also get access to all the previous episodes, which I'm pretty sure there will be many that are of interest to you. Another thing that you can do to help not just your own environment, but the entire industry is to share this episode with friends and co-workers, because it helps more people in our industry to get educated, and an educated rail signaling industry is a better industry. With that said, thank you very much. Hope to see you again soon, and bye for now.